at it topic by topic, I want to have a look at the binomial expansion. And where do we start with that? Well, we simply start with looking at how to sort of expand a simple function like this one. Let's start with x plus y all squared. Now this is very easy to do. We simply think of this as x plus y times x plus y. We multiply x by y and x by x, and then y, x by y and y by x and y by y. So we call this the claw as one way of doing it, and this gives us x squared. X times y gives me xy, x times y gives me xy, and y times y, y squared. Collect the like terms, and this gives us x squared plus 2xy plus y squared. Quite easy, GCSE level maths. Let's do the next one, x plus y, this time cubed. Well, the way I would do this is I would multiply x by y as I have just done, and I get my answer, which is x squared plus 2xy plus y squared, and then I would multiply that by x plus y, and in each case then we're going to multiply x by each of those and y by each of those. Let's see what we get. We get x cubed, we get 2x squared y, we get plus x y squared, and then multiplied by y we get x squared y, we get 2xy squared, and then we get y cubed. Let's collect the like terms here. We've got an x squared y, I've got another x squared y, that gives me 3x squared y. I've got xy squared, so I've got plus 3 of those, plus y cubed. Now this is giving me a set which is looking something like this. I've got a 1, 2 and a 1. There was that one. 1, 2 and a 1 up there. 1, 2, 1. Down here I've got 1, 3, 3, 1. 1, 3, 3, 1. So this is our second order derivative, this is our second order, this is our third, so this is our x squared, this is our x cubed. If I was to do my x4, then this is 1, 1 and 3 make 4, 3 and 3 make 6, 4 and 1. And this is Pascal's triangle. Let's carry on a little bit. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. So if I were asked to work out what is x plus y all squared to the 6th, I could just look at this and I could write it down. It's going to be x to the 6 plus, and if we watch a pattern, we've got x to the 5 plus x to the 4 plus x to the 3 plus x squared plus x. And then if we've got our y, what we've got, if we could put in here, this will be y this will be y squared, this will be y cubed, y to the 4, y to the 5, plus y to the 6. Now let's go and put these numbers in. 1, 6, 15, 20, 15, 6. And I have expanded that little function. Now, in the same way, if I was asked to do a simple one, let's suppose I'm asked to do an x cubed one. Let's look at an x cubed, and let's do x plus 2y cubed. We can just write this down and see what we're going to get. So if it's a cube, we're going to get this 1331. So I know we're going to get this sort of order. So we can work out that I'm going to have 1 x cubed. Then we're going to have here 3, and we're going to have our x squared, and we're going to multiply that by my 2y. Then we're going to have my 3, this time it's going to be an x, and we're going to multiply this by 2y all squared, plus we're going to have a 1 here, which is just going to be my 1 times my 2y, this time cubed. Let's work out what this is going to be. So this is going to be x cubed, plus we're going to have 2, 3 is going to give me 6, here x squared y, plus that's going to also give me here 2y squared, so that's going to give me 4y squared. 4 3s are 12, so that's going to give me 12 xy squared, plus 2 cubed is going to give me 8y cubed. And so we can work out these binomial expansions quite easily, really. They're not really that difficult, but sometimes if you're given something a little bit harder, like x to the 8, x to the 9, x to 10, then it's going to get a little bit harder, and in that case then we might want to try and use a calculator to try and help us. So let's have a look and see what we can do with some of these. So let's work out how we can do this. Now there are various ways of trying to think about the binomial expansion, and we've looked at some very simple ones here, but we can think of it as factorials. A factorial, if I write something like 3 exclamation mark 3 factorial, that's the same as saying 3 times 2 times 1. Now we could also use this on the calculator, and we call this NCR. So we can work out how one of these things work. So let's look at a little bit of our Pascal's triangle. So let's take our x to the sixth row of Pascal's triangle. So this is 1, 6, 15, 20, 15, 6, 1. Now I've got that, and what I'm going to use now is my calculator in NCR mode to try and work out where we're going to try and do this. So what we're going to try and do is work out here on the nth row, which in other words is going to be the 6th row. We're going to press the NCR button, and what we're going to do is we're going to say this is position 0, this is 1, 2, 3, 4, 5 and 6. Let's see what we get. So let's call up the calculator and see what we get here. So what I want to do is put in 6. I want to do NCR, that's shift, and down here on the divide sign, and we're going to do the 0th row, and that will give me 1. So that was 6, press the NCR button and put in 0, and that gave me 1. 6 NCR 1 this time, and we should get the number 6. Let's see if we do. So 6 NCR 1. I don't think I got the NCR in there. Let's do 6 shift and then 1. There we are, looking better, and I do get 6. And if we try the next one, 6 NCR 2, we get 15. And there we do. So we can work out these different numbers if we want to by using this NCR button on our calculator. So this helps us try to work out what we're doing when we come to working out Pascal's triangle. Let's look at the binomial expansion then itself. And to try and do a binomial expansion, we can try to work out some of these numbers. Let's try one here, and we could try a simple one as 1 plus, I don't know, 2x to the 10. And often when we get these sort of questions, we ask here to find the first 4 terms. So let's have a look and see if we can try working out this. Well, my first number is going to be really easy. That's just going to be 1 to the 10. My second number I've got to do is going to be my NCR, and I can write that as 10 over 1, and that's going to be of this number, which is going to be 1 here to the 9, because it's going to go down, and we're also going to multiply that by our next number, 2x. My next function is going to be my NCR, which is going to be 10, 2. This is going to be 1 to the 8, because they're going down in order, and this one is going to be 2x all squared. Let's do one more term, because we're asked to find the first 4 terms. So there's our first, second, third. Let's find our fourth. This is going to be 10, 3, 1 to the 7, and this is going to be 2x all cubed. So now we need to work out what some of these are going to be. Well, 1 to the 10 is easy, that's 1. We can do this 10, 1, so let's go along to the calculator, and I'm going to simply put in 10 NCR 1, and that's going to give us the value 10. Now,
sorry, I'm not sure.
That wasn't too difficult to actually work out, because we find that's always going to be the number that we're looking for on here. That is going to be multiplied by 1 to the 9, and 1 to the 9 is simply going to be here 1, and I'm going to multiply that by 2x, and I'm going to work out what that is now. So that's going to be 10 times 2, which is going to give me 20x. Let's work out the next one, 10, 2. So here, let's go and put it in 10 NCR 2, and that's going to give me the number 45. So this is going to be plus 45 times 1 times, this time 2 squared is going to give me 4x squared. So we want now 4 45s. 2 are going to give me 90, that's going to give me 180. Squared, and let's work out my last one. So this is going to be NCR 3, so 10 NCR 3, that's going to give me 120 times 1 to the 7, which is 1, times 2 cubed, which is going to give me 8x cubed. 8 120s are going to give me 960 x cubed, and I've managed to expand this using NCR to try and help me. Not that bad trying to have a go at trying to do this. Now, sometimes they might ask something a little bit different, and they might say we've got an expansion which is a plus b to the n, and they may say, can you try and calculate for me the coefficient of perhaps a to the 4. So we might have something we can work out here. So let's have a sum. Let's make one up. Let's go for something like 2 plus 3x, and we can choose what we want to have here. So we could go something like 12, and all I need to do now is to work out what the x to the 4 term is going to be here. So we've got my NCR, which is going to be 12, 4. Then what we want to have is this number, and I've got to work out what it's going to be at its 4th point. So it's going to be 2 to the 12, 2 to the 11, 2 to the 10, and we're going to have here 2 to the 9. Times, and this one, if it's at the 4th one, is going to be times 3x to the 4. So we need to work this out. We can go to our calculator. We can work out NCR. This is a 12, 4. So we do 12 NCR 4, and we get 495 times here, 2 to the 9. My maths isn't that good here. We'll go off and cheat with the calculator, and I can do 2 to the power of 9. And what a surprise, it's actually 512. And then we want 3 here, 3x to the 4, and 3x to the 4, not quite as bad trying to work out what 3 to the 4 is going to be. So 3 to the 4 is going to be 81 x to the 4. And now all I need to do is to multiply these out. So I've got my 512, I'm not going to bother to change that, times by 81 times by 495 gives me that massive number. $205,286 40 x to the 4. Huge thing. So we can see that often we don't need to go to extreme lengths here with some of these. So that gives us some idea about trying to solve some binomial expansions. And generally, when we've got to some of these bits, we're looking at an x function, then we look at an x squared function, an x cubed, an x to the 4, x to the 5. Gradually we're getting to rather smaller and smaller numbers when we come to work some of these out. So usually we can work out an approximation for our binomial expansion just by looking at the first few terms, because the other ones are normally so many decimal places down the line, then it doesn't sort of matter too much. So let's have a look at the first 4 terms of something that is fairly horrible. So looking at something, we might have something like 1 minus x over 4 to the 10. There's a typical function that you might get, and we're looking at the first perhaps 4 terms. We do the same as we've done all along, so this is going to be 1 to the 10 for the first one, plus this is going to be 10 1, our NCR, this is going to be 1 to the 9, and then we've got this bit which is going to be times by minus x over 4. There's our first term, our second term. Let's do our third term. Our third term is going to be my 10 2. This is going to be 1 to the 8, and then we've got minus x over 4 squared. There's our third term. And then our fourth term is going to be my NCR 10 3 of 1 to the 7, and then this is going to be multiplied by minus x to the 4 over, to the power of 3. Then what we've got to try and do is just simply work these out. So this is going to be 1 plus, can you guess what this number is going to be? 10 to the 1. Let's go off and do it on the calculator. So 10 shift NCR 1, and that gives me the value of 10 times here 1 to the 9, which is 1, times by minus x over 4, plus this one's a little bit more difficult to work out, so we'll work out here it's 10 NCR 2, and that gives me 45 times 1 times, this is going to be minus x squared over 16, plus here we're going to work out our last one, our NCR, so it's going to be 10 NCR, and this time it's going to be 3, gives me 120 times 1 times minus x cubed, and we've got 4 cubed, which is going to give me 64. So now we can get to the stage of trying to multiply this out. This is going to give me 1 plus 10 divided by 4 is going to give me 2.5 x, but it's now going to be multiplied by that, so this, instead of being a plus, is going to be a minus. Now I've got to try and work out the next one, which is basically going to be 45 divided by 16, which is going to give me plus 2.8125 x, this time squared. Then we're going to end up with minus, and this is going to give me 120 divided by 64, which is going to give me 1.875 x cubed. And there is our first 4 terms, and we've got an answer. Now, where are we going with this? Well, let's suppose we want to try and work out something, and we want to work out the value of a number, and they give us a number, and let's say it's going to be 0.975 to the 10. Now there are 2 ways of doing this. The first way is now with a calculator incredibly easy. So all I have to do is put in 0.975 to the power of 10, and that's going to give me my answer, 0.7763. Okay, so that was easy, but what we're going to try and do is use my binomial expansion to try and work this out, and we'll see how accurate we actually get. So basically what number we want is we want 1 minus x over 4, and that is going to equal 0.975. So my value of this if I'm just going to work out what x to the 4 is going to be, is we're going to take that over there, that bring it over there, so it's going to be 1 minus that number, which is going to give me 0.025. Multiply that by 4, and that's going to give me x is going to equal 0.1. So I've now got a value for my x. I can now substitute this back into there. So 0.975 to the 10 could be the same as my binomial expansion, which is going to be 1 minus 2.5 times 0.1 plus 2.8125 times 0.1 squared minus 1.875 times 0.1 cubed. Wow, long, nasty little thing to try and work out. So let's work out what these are going to be. So 0.975 to the 10, doesn't matter, you can't see that, I want this bit, which is the more important bit, is going to be 1 minus 2.5 times that is going to give me 0.25 plus, now we're going to get a little bit more difficult, so that's going to give us 2 decimal places, 0.028125 minus, and we're getting much smaller here, this is going to be 0.01875. Now I've got to go and put that into the calculator, try and work out what we're going to have. We're going to compare it with that answer. So I've got 1 minus 0.25 plus 0.028125. This is where it's always much more useful to put them in the calculator and store them in the memories. And if I've got all of that right, we end up with a number which is 0.77625, and I'm going to round that to the number of decimal places. It said 4, let's say 4, because that's then going to give me 0.1763, and my number here is the same. It's a lot of effort to go through, but in the days before calculators, this was the way of trying to do it. And you wonder whether in fact did the calculator actually do that to try and work it out. You'd be surprised. So we've got then some simple binomial expansions. Let's make these a little bit more fun and cause a little bit of a problem. So let's expand one that's a little bit more difficult. Now, when we try and expand a number, it's not really that difficult to work out what we're doing. We're doing here a plus b to the n, and when we've tried to do that, that's not really too bad. The problem comes when I want to do something like, someone says, can you expand 1 over 1 plus let's see if we can write that in. First of all, in index form, that's going to be 1 plus x, but this time it's to the minus 1. And let's see what happens when we try to expand this. So our first number here is going to be 1, and then I'm going to add to that, well, it's going to be here minus 1 times x. And now, what have we got? Well, it starts getting more difficult here. So to try and do this when we've got a negative factorial series, then we can write this as 1 plus x to the n gives me 1 plus n x, which is really what I've got so far, but then it gets more difficult. So I need now n times n minus 1 over 2 factorial x squared plus n times n minus 1 n minus 2 over 3 factorial x cubed, and so on. So if I get to here, then what I've got is my number, which is going to be minus 1, times n, which is minus 1 minus another 1, which is going to give me minus 2, all divided with x squared, all divided by 2 factorial, which I can work out is 2 times 1, which is 2, plus, let's work out the next term, it's going to be minus 1 times minus 2 times minus 3 x cubed, this time divided by 3 factorial, which is 1 times 2 times 3, which is going to give me 6. Let's take this down here and work out what we've got. So I've got 1 minus 1 times x is going to give me minus x. Alexa, stop. Thank you. Get in there before it starts throwing horrible words at me. And then I've got 1 times 2 is going to give me 2, divided by 2 is going to give me here 1 x squared, so that's going to give me plus x squared, and then I've got this to multiply out, which is going to give me minus 6 over 6 gives me minus 1 minus x cubed, and I've got here a nice little sequence that's basically here going to sort of carry on with the x 1 minus the x plus the x squared minus the x cubed, and that sequence would in fact continue on. They're not going to give you nice ones, are they? They're going to give you horrible ones to try and do. So let's have a look at the sort of thing that they might give you to try and do. And what they're going to give you to do is something like perhaps 1 over, let's choose something, 1 plus 4x. There we are. And you could have that squared perhaps. First thing we need to do is write this in index form. So that's going to be 1 plus 4x to the minus 2. Now as soon as I know that, I know I'm going to have to write that in this type of form. So let's work this one out. So this is going to be, working at each term, it's going to be 1 plus, and now we've got minus 2 here, and that is going to times by 1, which is going to be a little bit boring, times 4x. My next term is going to be minus 2, and then we're going to have minus 2 minus another 1 is going to give us minus 3. I'm going to ignore that sort of 1 because it's not going to do much when we multiply, and that's going to give me 4x here squared, and that's all going to be divided by 2 factorial, which is 2, plus let's do one more term, and this is going to be minus 2 times minus 3 times minus 4 times 4x all cubed divided by 3 factorial, which is 6. Let's see what we can do to work these out. This is going to be 1 plus minus 2 times minus 4 is going to give us minus 8x. I got a bit enthusiastic putting my plus down there. So minus 8x. Minus 2 times minus 3 is going to give us minus 6. Take away the minus is going to give me plus 6. So plus 6 divided by 2 is going to give me 3. 3 fours are going to give me 12. 12 fours are 48. And then 2 threes are 6. 6 fours are 24. 24 times, we'll just leave that as 24. 24 divided by 6 is going to give me 4. So I've got 4, which is minus 4, and I'm going to times that by 4 cubed, which is 64. 64 fours are 256. So minus 256 x cubed. And we have managed to expand that negative binomial expansion. So they're not really that bad trying to do some of these, but we can have quite a few nasty problems when we start trying to do some of these things, and they just really get harder in terms of numbers and mental power that you need to sort of bring in. Let's look at a couple of other sort of problems that you might get. Something like you might get the square root of something like 4 plus x. Well, we write that one, of course, in the term of 4 plus x here to the half. Now, my 4 here is a bit of a problem because we need really a 1 there. So what I need to do now with this one is to do something with this 4, and what I can do is I can take the 4 out and say that's going to be 1 plus x over 4 to the half. But of course, that's all to the half, like that. So let's now see if I can do that. I can square root that. That's going to give me 2 times 1 plus x over 4 to the half. Now we could try and put in the binomial expansion for this, which is not looking terribly nice. So this is going to be 2 times, so let's start our binomial expansion. This is going to be 1 plus, and then it's going to be my number, which is going to be a half, and I'm going to times that by x to the 4, plus my next bit is going to be a half, and then that's going to be a half minus 1, which is going to be minus a half, times x over 4 all squared, all over 2 factorial, which is 2, and then let's do one more. I'm not looking forward to this one. This one's going to be a half times minus a half, and then that's going to be now minus 3 over 2 times, this is going to be x to the 4 cubed all over 3 factorial, which is going to give me 6. Basically now all I've got to do is try and get this into the calculator, and that's going to be 2 plus, let's see what we got. We got 1 half. That's going to give me x over 8 plus a half times a half is going to give me minus a quarter times divided by 2. It's going to give me x squared over 128 plus, oh, it's too difficult for this one. This one I won't do in my head. We'll cheat and we'll go to the calculator, and simply I've got then to put in a half times minus a half times minus 3 over 2 gives me that 3/8, which I could work out, but the 3/8 then is now divided by, multiplied by 1 over 64, that, divide that all by 6, gives me 1 over 24. So that's going to give me x cubed over 1024. Now we're going to multiply everything by 2. That's going to give me 2 plus x over 4 plus x squared over 64 plus x cubed over 512. and that gives me my sequence. I've made a mistake. I've got my minuses, haven't I? I've left that out, so the x squared will be a minus. When that comes out, it's going to be a minus. Yeah, leave that one there. So, yep, there was my minus. That looks all right. And there is my expansion. That's going to be one of these infinite expansions. It's going to converge, and it's really not that nice to try and do. So there we are. There is the binomial expansion, trying to have a look at what we can do with this with some positive and some negative values. There are more difficult things we can do with this, like getting into partial fractions and other things, but that's going to get too difficult until we actually look at some of those. So we'll have a look at those next time. So until then, if you like what you saw, then please subscribe, and I'll see you again next time on A-Level Maths topic by topic. Bye bye.